Okay, we are going to go ahead and get started. We've got a great number of folks that have seemed to have popped on already. My name is Chris Neidl. I am going to be your moderator and co-host. I'm one of the members of the OpenAir Collective. This action seminar on low-embodied carbon concrete and local government leadership is being co-hosted by the Village of Hastings-on-Hudson in New York and the OpenAir Collective, a 100% volunteer network that is driving the advancement of negative emissions technologies, including low-carbon concrete at the state and local level. You'll hear more about that later, but you can check out the openaircollective.cc for more information. So this seminar that we're doing today is actually kind of, some of you, I believe, have probably attended the webinar that we did back in the end of June, which was about the Village of Hastings-on-Hudson's resolution in support of low carbon concrete. And we heard from Mayor Nikki Armacost and some members of her board. This is sort of a follow-up to that, where we're going to see some of the progress that's been made in Hastings, but we're going to give a more general presentation again on the connection between concrete and climate, and uniquely the role of local governments in really driving progress. So just to run through the discussion today, I'm going to go ahead and start off with a presentation that again is going to make that linkage again between concrete and climate, but then really talk about the special role of local government leadership. And then we're extremely excited to have Professor Matthew Adams from the New Jersey Institute of Technology. He's a leading expert on the subject of low carbon concrete. And he's going to really talk about what do we mean by low embodied carbon concrete, all the different things that that can mean. And then we're going to move on again to really discuss the progress that's been made in Hastings. Since the resolution was passed just in May, they wasted no time at all in getting going on that. And I think they're providing a really interesting template or some footsteps that other local governments, villages, municipalities, and counties here in New York State and beyond can definitely follow. And then importantly, we're going to end what makes this an action seminar is we want to invite folks who are joining us. You know, this is just looking at the RSVP list, I see local government leaders and local activists and volunteers, not only from all over New York State, but also New Jersey, Massachusetts. I see in the chat, we got some folks from Milwaukee, certainly out in West Coast, Canada, and some folks from the UK that I've been able to confirm. So the invitation here is to join our network, and we can collectively figure out, share information, and figure out ways to advance low carbon concrete on the local level. What I'd like to do is real quick, you'll notice is we're not going to have a Q&A as part of this 90 minutes with attendees. But what we are doing is we're creating a permanent Q&A at our newly launched website. This is the Low Embodied Carbon Concrete Network, or lecwork.org, which just launched yesterday. You can go on there. There's some resources, but if you hit join, you'll be admitted into our forum, and there we're going to have a forum specifically following this webinar where any questions that you want to ask can be asked permanently. So it's not just something we're going to have to cram into the last 20 minutes of today. So I invite you to go ahead and take a look at that, and I'll speak more to that towards the end of the presentation. So what I'd like to do before we kick off is allow Mayor Nikki Armacost from Hastings-on-Hudson give us her welcome.
Hi, everyone. Thanks so much, Chris. On behalf of Hastings-on-Hudson in New York and the OpenAir Collective, welcome everyone. Especially all of you from other parts of the country, from other countries, from Canada and the UK. That's pretty exciting. It's really wonderful to have you all here at this second webinar about low embodied carbon concrete. Special thanks to Chris and his team for making this happen. And as Chris mentioned, our first webinar was back in June of this year, where we discussed the impetus for passing the resolution committing our government to promoting the use of low embodied carbon concrete for building and infrastructure projects. At the end of that webinar, we discussed how super it would be to explore this topic more deeply, and hopefully this webinar will do just that. So thanks to everyone for joining us, and over to you, Chris, to move the webinar forward.
Thank you so much, Mayor Armacost. Really appreciate it. So I will go ahead and start us off, as I said, and provide a little bit of background here. So just again, I think this is becoming increasingly known from folks that are focused on climate, but concrete definitely intersects with climate and is a key area that we have to address in order to address climate change. And just on the highest level, the key thing to think about is just that drives much of this is just how ubiquitous concrete is. Concrete is everywhere. It is the second most used substance on earth after water, the most used building material. We produce over 10 billion tons of it per year globally. It's literally the foundation of the modern built environment. And that's not going to change, or it's not going to change within a time frame that's meaningful to the climate. And that's not something that we necessarily want to change. And the reason why is that concrete is an excellent and unique material that is incredibly versatile and can do many, many different things. But it's also, even if we had some substitute for concrete tomorrow, the use of concrete is so embedded in our architectural, engineering, construction practices. It's so foundational that the ability to change that and learn another way of building our environment would take a really, really long time. And then finally, it's just the materials that make it up are incredibly abundant and accessible, and therefore they can meet actual growing global construction demand like no other material. So concrete's here to stay. But again, in zooming down a little bit in terms of what exactly are we talking about when we're talking about concrete and climate, there's two important ideas that I find really helpful in taking a measure of that. The first is embodied carbon. And this is a term that folks who are focused on climate and climate action are increasingly becoming familiar with. And embodied carbon is the carbon that is produced, or the greenhouse gases that are produced in making things, as opposed to operational carbon, which we usually focus on or tend to prioritize, which is emissions generated by the use of things. So taking the example of a car, the embodied carbon of a car is all the carbon that was produced in making the steel and the rubber and the plastic and all the parts that were required in the manufacture. But the operational carbon is the burning of gasoline in the internal combustion engine over time. And when embodied carbon is, particularly now when we think about this incredibly important period over the next 3 years in which we have to take accelerated dramatic action, embodied carbon happens up front. And if you look at just the built environment, which is a major source of emissions, about half of all emissions will come from embodied carbon during that period of time. And when we're talking about concrete, not surprisingly, we're obviously talking about the emissions that are produced in the making of it, or if it's embodied carbon. And specifically, though, when we look at the ingredients of carbon, it's really one ingredient in particular, Portland cement and conventional concrete, that is the real carbon culprit. It only makes up about 10 to 15% of the volume of concrete, but it's responsible for about 85% of emissions typically. And if you add all of that up across the globe, it's about 8 to 7% of total global emissions come from Portland cement. I believe I heard a statistic, if it was its own country, it would be the fourth largest emitter on Earth. And so the key, and Professor Adams will get into why that is in his presentation. So the key here, a lot of when we talk about decarbonizing concrete, it's really about reducing or substituting conventional Portland cement, and then also reducing the actual embodied carbon of cement itself, making that less carbon intensive. And that I generally refer to as cement reduction, and then also reform, the changing of its environmental impact. And when you do those things, and as Professor Adams will show you, there's not one way to do that. There's many different ways in which that result can be attained. Any type of concrete that utilizes some of those methods, we refer to as low embodied carbon concrete, or LECC is the term that's increasingly used. You'll hear us refer to that. Now, the other idea, which is really exciting, and to be honest, what really has brought the OpenAir Collective into this, is the concept or the idea or the reality of carbon negativity, or being carbon negative. You increasingly hear this as well. And to be carbon negative, this is a term that can apply to a material, a product, a place, or even a person or an organization. And that's when the production and use of something results in more CO2 being avoided or removed from the atmosphere than is emitted into the atmosphere. That's carbon negativity. Confusingly, it's sometimes called carbon positivity, but I'm going to go with carbon negativity for this presentation. And that's not just like a cool idea or aspiration, it's actually essential. We now know that we've passed the point where we can just stop emitting greenhouse gases. We now have to withdraw massive amounts of carbon dioxide in order to stay within a safe level of warming. And many of the ways that we can do that, afforestation, soil management, are well known, but we're going to have to do a lot more than those in order to stay within our parameters. And concrete, excitingly, is a potential nexus or medium for that action for carbon negativity, and which is exciting because again, it's the second most used material on Earth. And so what kind of drives us at the OpenAir Collective is, can we not just aspire for lower embodied carbon concrete where we reduce the emissions profile of concrete, but can we get to no embodied carbon concrete or even negative embodied carbon concrete, where there's more emissions that are taken from the atmosphere in the utilization of concrete than are emitted in its production. And then if we get to that point, we're talking about, again, massive scale and an important emissions reduction. And again, that's what sort of brought OpenAir to the table originally, which sort of drives our action in this space. And in order to achieve carbon negativity for concrete, obviously it has to happen on top of all of those other reductions that I mentioned in the cement side of things. But broadly speaking, the universe of technologies and methods that we're talking about here to reach carbon negativity are what we call carbon capture, utilization, and storage. And so just to focus on the utilization part as it relates to, this is the use of carbon dioxide in concrete itself, which has huge potential. One thing that's interesting, sorry for the stupid graphic, I couldn't find a better sponge, but the one thing that's interesting about actual typical concrete is that over the long term, it naturally sequesters or mineralizes carbon just through contact over long periods of time. That's just a feature of concrete. You could call that natural carbon mineralization that just sort of comes with standard concrete. But what's exciting is with new technologies and methods that are, some are on the market now, some are on the horizon, some are further off, you can enhance that capability in a number of different ways. And this is a pathway to, again, driving us to neutral or negative concrete. So some of the ways, just at a high level, that we're looking at here are carbonation, which is when you take carbon compounds like calcium carbonate that have been made from carbon emissions, and you actually use those as substitutes or as enhancements for concrete. You're putting that carbon into the concrete itself. Related is a technology you might have been reading about. There's a few companies that have really developed a profile around this, and this is concrete CO2 curing, where at the end process, you inject carbon dioxide as a substitute for steam into concrete during the curing process, really at the end of the process. And that also reduces the amount of cement that you have to use. And then there's also more, a little further off on the horizon, but definitely a reality, is actually making concrete or cement itself, the carbon center of the material, out of CO2 waste materials. And what's exciting about this is these types of carbon mineralization methods and products can apply across all of the different ingredients that concrete is made up of. So there's a lot of opportunity to really store carbon in concrete. And there's a lot of different companies. Some range from ones that have product out in, hundreds of different plants around the world, and some again are at an earlier stage, but it is a very real thing that is starting to really move. Now, the other part to think about is the capture part, which is related to that. Where do you get the carbon to put in the concrete or to put in other places? And here there's big opportunities too. And this particularly, as you can imagine, since cement is the major source of carbon for concrete, if we can capture more carbon at the cement plant, that is where we're going to have our greatest reductions. And there's a couple of companies, actually more than a couple, some of the largest concrete companies in the cement companies in the world, LafargeHolcim, Lehigh, Heidelberg, are actually now starting to deploy on a pilot, and now this year on a commercial level, carbon capture right at their plant, where they'll be able to capture it from the stack and then either store or utilize that carbon for other products. And just to top this off, in order, what I just described, CCUS, it is key to getting us to negative ultimately, but it's also key to getting us really to zero or to low. In fact, there's been a lot of estimates. One leading report from last year from the International Energy Agency estimated that CCUS would really have to be responsible for almost half of all cement emissions reductions in order for it to meet the Paris Agreement levels by 2050. So when we talk about low embodied carbon concrete or negative concrete or neutral, it's a combination of, again, cement reduction reform and ultimately CCUS technologies. And one thing, and this will come out in Professor Adams' presentation, it's not one thing. It's many different types of things that should be thought of as ingredients that some are available now And over time, more options will continue to be available, and they're able to be combined in different ways based on what the goals and needs of an individual construction project are. So that's where concrete and climate intersect. Now, what are we talking about? We talk about a local government role. And again, local governments are generally at the forefront of moving quickly on climate. We're seeing that globally, whether it's cities, counties, or towns. A lot of the fastest, most creative action is happening at those levels of government. But with concrete, there's actually even something a bit more special in terms of the role. And that really comes down to the local part. And let me explain why. That's really because concrete is inherently local. It's produced locally, unlike a lot of the other sources of emissions, which have bigger, the origin of them might be in another part of the world. The ultimate production of concrete, the bringing together of all ingredients, has to happen locally. And that's just tied to the actual nature of the material itself. Its heaviness and shipping, but more that it's a wet product and it will dry out if it's shipped too far. So it's typically within a range of 50 miles is where you want to source your concrete from. And this map kind of shows it all. These are the points that show where the different, these are ready-mix concrete plants throughout the state of New York are, and they show that local pattern. There's a bunch of them. And local concrete companies, some of them are part of national conglomerates, and some of them, quite a few of them, are small, truly local businesses that are 1 plants, 2 plants, or 3 plants. That's the nature of the sector. And so looking at the example, let's take the beautiful city of Kingston, New York, in the central Hudson Valley. You know, when folks there want to get concrete for ready mix, these are the options if you look at sort of a 50 mile circumference. And so the question is well then where, what we just talked about, what Professor Adams is going to get into, when we talk about low carbon concrete options, where does the rubber hit the road, or the pavement hit the road, I guess is the better way of saying it. Where does that all happen? Who's the decision maker? How does that access occur? And the answer is mostly from conventional concrete plants. There are specialized products that come from their own plants, but many of the decisions with the largest impact really come down to what happens at these existing conventional concrete plants. And so to the extent that we want to start seeing these other solutions become available to us wherever we are, they have to be coming available at your local concrete batch plant. And so in order to make that happen, we need to demonstrate that there's local demand. They're not going to provide options or solutions if there's no demand. And then it's also the building of local knowledge. Is what are we talking about when we're talking about these LECC solutions? How do I use them? And what are their implications for construction? And here is where local government really comes in, where it can have a huge impact. There's a relationship there with these companies because they are local businesses right within your jurisdictions. But importantly, local governments buy concrete, as we know. They buy it for civic infrastructure projects, for schools and for roads and for sidewalks and for skateboard ramps sometimes. And so that's an important part where they can actually create that demand. They can signal that demand. And then the other part is education and awareness. And this is after the fact. You could have, a village like Hastings is using it, and then it spreads the word, and it lets folks within its community and outside its community know that it's doing it. But there's even a more important earlier step here in education. And this is where the Hastings experience is really interesting that we're going to talk about. And that's where it's really this education process that has to happen with all the different stakeholders that are involved in making projects happen, right? So it's not just local government, it's its public works commissions team. It's the contractors that are hired. It's the local town engineers that have to review, stamp, and sign off on. And then, of course, it is definitely the local concrete plant itself, which, again, it might be familiar with some of these options, but it has no reason to be familiar with them if nobody's demanding them otherwise. So what local governments can really do through initiating a procurement program is they can start driving the process whereby and play a role and do some of the lifting on the research, raising awareness among all these stakeholders to eventually answer these most basic questions that to get a project done, you need to. What does it mean about low embodied carbon concrete? What does it cost? Is it structurally sound? Is it as workable as normal concrete? Can I use it the way I typically use concrete for different applications? And very importantly, can I get it here? It's not useful to someone if it's an exotic idea that's in a lab somewhere across the country. So these are the kinds of questions that local governments can start to convene and get answers to. And then over time, you'll start to see through that movement, more of these options become available. And this is what we've seen with Hastings at an early stage, but it's moving very, very quickly. You can start to see the types of impact that that's having right within their backyard. And then one other thing not one other thing, but I think a really important part about local governments is, can we multiply our impact by all across a region doing this at the same time, pursuing these types of projects at the same time? So what if you had, again, Kingston begins to explore its low embodied carbon concrete options. But if you have a bunch of other communities right within the same area doing the same thing, you're going to start getting these options appearing throughout the region. And again, once the learning starts to happen, that the government starts to drive local governments and communities, that means that all parties involved, particularly the local concrete companies, they now know how to do that. They've done it before, they have that experience, and they can offer it more broadly for private sector projects as well. And what I think, just to close, here in New York State, and again, I want to emphasize, we're using New York State examples. We have a great global audience for this. And so what we're talking about obviously applies to anywhere. And in your state or province, you may have a similar type of program. But in New York State, we have this really wonderful program called the Climate Smart Communities Program, where communities can sort of certify, register, and then sort of undertake a number of low carbon climate actions, and they get a sort of a score for it. And while low carbon concrete is not included within that scoring, there already is this great backbone or this network of communities that have demonstrated that they care about climate and they want to take climate action. And they often have volunteers and actual professional staff that are dedicated just to that. So that's a great resource that can drive some of the things that I just described. And I know that we have a lot of folks here from New Jersey as well. Sustainable New Jersey is a very similar program. It almost looks identical. And I'm sure in states across the country and in jurisdictions across the world, there are similar types of resources that can be drawn on. And again, we're going to hear an update from what Hastings is up to, what their experience has been shortly. But what we're first going to do is take a little bit of a deeper dive with Professor Matthew Adams from NJIT into what is low carbon concrete and what are the sort of dynamics between options. What if you really wanted to say, I want to do low carbon concrete, what might that actually look like?